Hey guys, moving on to 8.2, quadratic functions in vertex form. Okay, so everything we do today is going to be based off the vertex. So if you'll remember, the vertex is kind of where the parabola changes direction. Okay, so we're talking about vertex form, and this is vertex form right here. Copy that down. Y equals a times x minus h all squared plus k. Okay, so based off this, we can find exactly where the vertex is going to be located based on the equation given. Just a reminder that this was y equals x squared. All right, so what we used in chapter 7 is standard form ax squared plus bx plus c. Again, here is vertex form. Okay, so we're going to be using this form in order to solve. All right, so we're going to start off with one piece at a time of this vertex form. Okay, so let's break it down. We're just going to take ax squared plus k. So we're going to take ax squared plus k. So we're leaving out the minus h for now, okay, because this k does something in particular to our graph. So right here I have the, again, y equals x squared graph. I want to know, what does y equals x squared minus 4, how does that change our graph? Okay, well, if I plug in -2, -1, 0, 1, and 2 into here, I get 4, 1, 0, 1, 4. Okay, 4, 1, 0, 1, 4. Okay, over -2, up 4, over 1, up 1, 0, 0, over 1, up 1, and over 2, up 4. Okay, now when we take that same x squared, but we subtract 4 from it, we've seen this before, guys, when we talked about absolute value functions, where it had the v-shaped and it moved around. Okay, so if we just take something like -4 outside, okay, and if I were to plug everything in like -2 for x, just like we did for this one, -2 squared is 4. 4 minus 4 is 0. So my new point, instead of being at -2 comma 4, is now at -2, 0. My new -1 is at -3. My new 0 is down here at -4. My new 1 is down here at -3. My new 2 is here at 0. So what this does is it just moves everything, every point gets moved down 4 spaces. All right, -4, down 4. So what do you think is going to happen with y equals x squared plus 3? All right, everything is going to get moved up 1, 2, 3 spaces. Okay, our other one was at 1 comma 1, so that's going to move up 1, 2, 3 spaces. Okay, and again, you can plug these in. Over 2, up 1, 2, 3, 4. Each point in 1, 2, 3, 4, and find out where the new points are going to be. Okay. All right, so this is the axis, x-axis, so it just moved up 3. 1 and 1, because it's x squared, it's just 1x squared. So these points don't move out or in. Okay, nothing to make it narrower or wider. So if you have just x squared plus 3, we move it up 3. Just x squared minus 4, we move it down 4. If it was x squared plus 10, we would move every point up 10. If it was x squared minus 1,000, we would move every point down 1,000 and have that same exact parabola as long as it's 1x squared. So I want you to try y equals x squared minus 5. Pause the video and try it. Okay, so the vertex for x squared is at 0, 0, so we're going to move everything down 1, 2, 3, 4, 5. 1, 1. Now, how am I knowing where to put these other points? Well, because again, we have x squared. If we look back to our original x squared, we had 1 over 1 and up 1 from the vertex, over 1 and up 1 from the vertex, over 2 and up 4 from the vertex. So I did the same thing. From that vertex, over 1 up 1 each way, over 2 up 4. And so again, we have this axis of symmetry where everything is exactly the same. So because it was over 2 here, I knew I could move it over 2 here, and there are my arrows. Okay, now let's talk about the other part, that x minus h squared part. Okay, so if we are plugging a number in for h, okay, like x minus 3 squared, all right, so the 3 goes in for h, what is that going to do? All right, so let's compare it to, again, our parent function of equals x squared. All right, so if we go ahead and we create our parentheses, x minus 3, move it outside, raise it up to the second power. What is that going to do? Okay, you can see that our new one, the red one, is moved over 3. And from the vertex was moved over 3. Okay, so simply when you subtract 3, you would think that it would move it 3 to the left, but it actually moves it 3 to the right. Okay, and so what would happen if we had x and we plugged in a negative 3? So that would make it x to the minus 3, which is actually x plus 3. Okay, so based on what we just said there, if we raise this up to the second power, it should move it 3 to the left. Okay, so inside it moves it the opposite way you would think. Okay, it moves the vertex the opposite way you would think, and again, it's going to be over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. This is all based on the parent function of x squared. Okay, so what we're saying is if inside those parentheses we have an x plus 4, it's going to move us to the left. How many spaces left? 4 spaces left. Okay, because we think it would move it right, but it moves it the opposite. It moves it left. Everything inside. Inside moves it left and right. Okay, so right when it's a minus. Okay, you're going to move it right when it's a minus, so x minus 6. You would think it would move it right. I'm sorry, you think it would move it left towards the negative, but it actually moves it right towards the positive and move it right 6 spaces. That's where the vertex would go. Okay, so if I were to give you a problem like this and ask you to graph it, okay, x minus 5 squared, I would want you to draw just like this, okay, x minus 5, I would think it's going this way, but I know because it's inside, it goes the opposite. 1, 2, 3, 4, 5. There's my vertex, and because there's nothing out here, over 1, up 1, over 1, up 1, over 2, up 1, 2, 3, 4, 1, 2, 3, 4. And there's my vertex. So I expect you guys to be able to do this without a calculator, okay? Without a calculator. Okay, so let's piece the two together, okay? So we have our plus k outside, so our plus 3 outside. We have our minus 2 inside. All right, so let's see if we can move. This means we're going to move the vertex in 2 ways, okay? Because we have a minus 2 inside, that means we are going to move left or right that many spaces. So because it's minus 2, we're going to move right 2. And because it's plus 3, that means we're going to go up 1, 2, 3. There's our vertex. Okay, inside means left or right. The outside means up or down. Okay, so the inside moves it the opposite way you would think. We get our over 1, up 1, over 2, up 1, 2, 3, 4. Over 2, 1, 2, 3. Oops. 1, 2, 3, 4. Okay. And let's just take a look at the textbook for some other examples. Okay. So x minus 1 squared minus 3. So because it's x minus 1, it moves it over 1. Because of that minus 3 outside, boom. There's our vertex. So what's our vertex located at? Where the change is at 1 comma negative 3. This one, minus 1, again, we're moving to the right. 1. Plus 2, it goes up 2. There's our next point. That's our vertex. Our vertex is located at 1 comma 2. Next, we got a plus 2 inside, so that means we're moving 2 left this time. We got a 1 outside, so we're moving down 1. Okay? So that's the vertex. That creates the vertex. We draw the parabola from there. All right, so you're going to be asked, where is the vertex located? Okay, so negative 2 comma negative 1. All right, so you notice the y value is always exactly the same as the plus or minus outside, and the x value is always the opposite of what is inside. Okay, now, very important, the axis of symmetry that splits it up, okay, the axis of symmetry is x equals h. Now you remember, as you can see the cursor up here, H is located inside, so it's that number inside, 1, 1, 2, or -2 in this case. So wherever the vertex is, that is x equals -2. That's the axis of symmetry, the imaginary vertical line that splits the parabola in two. In this case, it's x equals 1. In this case, it's x equals 1 again. Now you're saying, well, those are minus, Mr. I. Why is that? Well, notice it says just the h value. X is equal to just the h value, so you ignore the negative sign and just take whatever the h value is itself. So the axis of symmetry, x equals 1, x equals 1, x equals -2. And if we go quickly back to here, the axis of symmetry would be x equals 2. That's the axis of symmetry, or AOS. Sometimes you'll see that abbreviated like that, is x equals 2. And the vertex is at 2, 3. Okay, so you may be asked to do something like this on your homework. Over 2, up 3. 2, 3. Okay? Vertex is H, K. Okay? H, K. All right.